Assalamualaikum and very good morning. My name is Yoyo and my YouTube number is AD170126. Today I will be explaining to you about the introduction for our project. First of all, the kinetics come from the Greek word for motion. As was already mentioned, kinetics is the branch of mechanics that deals with the analysis of motion of particles and rigid bodies in space, but from a geometric point of view, that is neglecting the force and torque that produce the motion. We start by discussing Yoyo's laws for a rigid body. These laws are known as the balance of linear and angular momentum. An alternative form of these laws is also presented that is useful for solving many classes of problems. These are the motion that we discuss in kinematics. First, translational motion. Translational motion is the motion by which a body shifts from one point in space to another. One example of translational motion is the motion of a bullet fired from a gun. Next is rotational motion. Rotational motion deals only with rigid bodies. A rigid body is an object that retains an overall shape, meaning that the particles that make up the rigid body remain in the same position relative to one another. Last one is circular motion. Circular motion is a common type of rotational motion. Like projectile motion, we can analyze the kinetics and learn something about the relationship between position, velocity, and acceleration. Newton's first law states that an object in motion remains in motion at constant velocity unless acted upon by an outside force. For uniform circular motion and online motion to measure the position, velocity, and acceleration, both components are limited or unlimited undergoing circular motion. For objective for our group project is to find the angular velocity of the Yoyo. The Yoyo has been dropped down and up from a certain height. We can use Newton's law to look up for the torque produced by the tension, then calculate the acceleration. Is then use the kinematic equation to calculate the speed or use conservation of energy. Second, Newton's law should be associated with our group project or any other parameters such as principle of work and energy, impulse, and momentum. Direct and oblique effect need to be applied and draw the kinematic further. Thank you.
For our group assignment, we decided to pick a yo-yo as the main subject. We will find how a yo-yo works using a simple rotational theory in dynamics. Basically, a yo-yo has a cylindrical shaped body with a string or rope attached to the center of the yo-yo. With the knowledge regarding dynamic subject, we will see how factors such as inertia, gravity, and theorem of a rigid body will affect the movement of a yo-yo. In this type of problem, it is very important to realize where the application of the force is acting. And for the methodology, first we have to know that torque is equal to the force multiplied by the perpendicular distance from the rotation axis. So if the cm is the rotation axis, then there is no torque from gravity as the distance from the rotation axis is 0. So the first step in the investigation is to collect data of the yo-yo that is winding up and down. The position of the point near the rim of the disc and marked by a sticker P1 is measured in a slightly moving coordinate frame whose origin is the hand of the person holding the end of the cord of yo-yo. Point tracking is used to collect automatically coordinates of point of interest. The red boxes illustrate the area of the software search in the current frame of the video clip for the origin and for the point marked by the sticker. In the upper right diagram, the horizontal and vertical position of P1 are plotted against time. This is combined with a sinusoid sinusoidal feet of the horizontal displacement of the yo-yo due to an unintentional perpendicular motion of the yo-yo, and a quadratic function feet of the vertical position during the first phase in which the yo-yo unwinds. This feat can be used as coordinate function of a compute point that is displayed in the video clip part 2. It turns out to be the position of the axle during the unwinding phase of the yo-yo. The lower right diagram in figure 1 shows the orbit of point P2 while the yo-yo is unwinding.
Assalamualaikum warahmatullahi wabarakatuh, and hello. My name is Muhammad Zarfan Nabi Ahmad Azri with metric number AD190086, and in this video I'm going to talk about our calculation. So here is our question. A yo-yo of diameter 6 cm and mass 50 gram has an accelerometer of 10 mm, around which a string of length 1.15 is wound. Use the principle of conservation of energy to calculate its angular velocity of the yo-yo when it is allowed to fall and unwind under gravity. The first thing first, we need to draw our free body diagram, and then we need to highlight all the value that it gives us. Alright, so in the question, it actually asks us to find its angular velocity using the conservation of energy. So first, as I said, we need to draw the free body diagram. Alright, so here is our free body diagram of our yo-yo, and here is our free body diagram when our yo-yo before its fall. So this is the position of our yo-yo before its fall, and this is our free body diagram of our yo-yo when it is fully unwound. So as you can see, our radius is 3 cm, and then we have a mass gravity, which is the direction of the mass gravity is towards ground, and then we have tension T, and then we put our length beside our tension. Alright, so this is our solution, which is our moment of inertia is I equals to mr square over 2, because a yo-yo is approximately a solid cylinder. So its spin about an axis through its center, we can use the following formula, which is I equals to mr square. So we just need to substitute our value, which is our mass is 0.05 kilogram times with our radius 0.03 meter square over 2, and then we will get 2.25 times 10 to the power of negative 5 kilogram times meter square. So that is our moment of inertia. And then because it asks us to use the conservation of energy principle, so we need to use Ke plus Pe1 equals to Ke2 plus Pe2. So the left side is for the position 1, which is the free body diagram that I have shown you, and the right side is for the fully unwound position, which is the fully unwound free body diagram. So when we are using conservation of energy, we can change the formula of kinetic energy and potential energy into 1 over 2 mv square plus 1 over 2 I omega square plus mgh equals to 1 over 2 mv square plus 1 over 2 I omega square plus mgh2. So this is our formula, and we actually need to simplify it. So when we simplify it, we will get omega equals to set 2 mg h1 minus h2 over mr square minus 1. So the things that we want to find is angular velocity, and omega is our angular velocity. So here we have our omega equals to set 2 mg h1 minus h2 over mr square minus I. And then we just need to substitute our value, which is set 2 times 0.05 kilogram times with 9.81, which is our gravity, times with 1.15, which is our length. Since one of the length is 0, so we will get 1.15 over with 0.05 times with radius, which is 0.05 square, minus 2.25 times 10 to the power negative 5. So we just need to get back our I that we have calculated in the top, set in the that we have just calculated in. So 2.25 times 10 to the power negative 5, we have already calculated. So we just need to put the I into the formula. And then we will get 105 rad per second. So 105 rad per second, we can also change it to revolution per second. In order for us to change it, we just need to divide it with 2 pi, and then we will get 17 revolution per second. And that's all from me. Thank you.
Okay, my name is Ahmad Adik bin Muhammad Najib, AD 190039. I will give a simple presentation about discussion for our project. Okay, for the discussion, based on analysis of case study and methodology with result obtained from the calculation just now, we found that angular velocity of the yo-yo can indeed be determined when it is dropped from a certain height. What is the height? The h height. Okay, the height itself we can obtain the height which the height is calculated from the finger to the center of the yo-yo release, or it can also be obtained when you hang a certain yo-yo, and then you calculate the distance of the center of the yo-yo from the floor, and then you release the yo-yo, and you find the final position for the center of the yo-yo from the floor, and then you can find the comparison between the two, and you can get the height. Okay, so moving, as yo-yo itself is a solid cylinder, it can be identified as a solid cylinder. The moment of inertia for the yo-yo can be found by using the formula for solid cylinder, which is I equal to mr square over 2, in which I is the moment of inertia itself, m is the mass, and r is the radius, and over 2 is its half of the m times r square lah. Okay, and then the yo-yo itself spin about an axis through its center. Following the formula, it can be said that the heavier the yo-yo, the more the inertia. Okay, so the continuation to finding the solution is by using the principle of conservation of energy. In this case, the yo-yo case, the principle of conservation of energy is Ke1 plus Pe1 equal to Ke2 plus Pe2, in which the 1 is the initial position and 2 is for final position. The Ke is kinetic energy and Pe is the potential energy. Okay, as stated in the question just now, there is no air presence, there is no air friction during the fall of the yo-yo, which can be said that the energy contained in the yo-yo throughout the whole process, which is the free fall process, can be assumed as energy at the top equal to energy in midway equal to energy at the bottom. So for the kinetic energy rotational, the formula for kinetic energy rotational is 1 over 2 I omega square, in which I is the moment of inertia. Just now, I is the moment of inertia, and omega is angular velocity. Angular velocity can be understood as the rotation of yo-yo per second in radian, which can also be related to linear velocity. In the question just now, all information needed was given, in which diameter the question just now gave us the diameter, in which diameter can be regarded as 2r, basically 2r, and the mass was given in kilogram. By following this given information, the moment of inertia for the yo-yo can be obtained, and as the moment of inertia can be obtained, the angular velocity can also be calculated by using the principle of conservation of energy. I think that's all for discussion. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Farid bin Razmi, metric number AD 190080. So we will go further for the conclusion. To sum up, we can clearly see that even a motion as simple as a spinning yo-yo have a very complex analysis and calculation in it. We have determined the angular velocity of the yo-yo when the yo-yo has been dropped down and up from a certain height. We have also used the Newton's law to determine the torque produced by the tension on the string of the yo-yo, and also the acceleration produced by the yo-yo has been calculated by implementing kinematics equation. We have also implemented the principle of work and energy as well as the impulse and momentum. And from there, the objective of this project and analysis has been achieved. Even though we are analyzing the problem by using terms like force, momentum, acceleration, angular velocity, which is something that we cannot clearly see physically, but it can be proved by the legit method and calculation. That is how important statics and dynamics analysis as a strong foundation in engineering studies. Fundamental method of analysis we have learned in the syllabus are now being implemented to analyze the real world problem. We have done an in-depth and details analysis on a yo-yo motion, which is explain why it move and behave like that, what makes it behave like that, as well as the behavior in terms of the force around it. This kind of project and analysis should be done for the other real world problem related to engineering, such as a structural analysis, the movement of a vehicle, etc. And we believe that this project will be a benefit for the other students, especially UTHM students in the related studies. And that is all from us. Thank you. Have a good day.